Okay, welcome back. We're going to do our final installment for now for naming and formulas. We're going to move on to a whole new class of compounds. These are called molecular compounds. We spent a lot of time on ionic compounds. There's lots of little rules and layers of complexity that we added there. We went over many of those rules. Just keep in mind as we go, there's all kinds of little nuances and conditions and exceptions that come up. All right, and I want you guys remembering that we're doing basics right now. Basics of chemistry, basics of naming and formulas. Because as you go too far down that rabbit hole, I'm going to overwhelm you guys with all these little exceptions and stuff like that. But keep in mind that is what happens in chemistry. The only always in chemistry is there's always exceptions, right? But we're gonna keep it as simple as we can, while still giving you a very, very strong foundation in naming and formulas for now. All right. So we have molecular compounds, and they are different from ionic. And we need to, from this point forward, from now until the rest of your career in chemistry, however far that may go, you need to be asking. And I can't stress enough at this point that from now on, this is your first question, because we have to apply a whole different set of rules to naming and formulas. All right. Now, I'm hoping at this point, you guys being the critical thinkers that you are, you jumped right to this question. Well, if I'm going to ask myself that question, how the heck do I know if it's ionic or molecular? And that's what we're going to get to in this video. We're not really going to get to how to name these because it's really pretty easy, and the Chem Quest will take care of that for you along with a little help sheet I give you. We're going to focus on making sure you can make that differentiation and quickly. All right, and it's not hard, it's just remembering some things. Let's get to it. Ionic compounds. First of all, you may have noticed that a metal is often, not always, often our cation. That's a direct indicator. If you see a metal as part of that equation, you know it's ionic, right then and there. Now, sometimes, though, we have an ionic compound where a metal is not present, but we do see a polyatomic ion. Polyatomic ion is an ion, therefore the compound is going to be ionic. What about hydrogen? Hydrogen is different. For now, we're just going to stick with the acid names. We will learn a little bit more about hydrogen's electronegativity and why sometimes it's molecular, sometimes it's ionic, because it just depends on the conditions and what it's bonding with. We're not going to worry. I'm not going to add that extra layer at this point. So we're going to treat the hydrogens with their acid names for now. But keep in mind, maybe back of your brain somewhere, you're going to remember that just because hydrogen is there doesn't mean it's going to be an acid. It's just that for now and for this upcoming test, when you see hydrogen as the cation, we're just going to go with that acid name. But please remember that hydrogen being present does not make an acid necessarily. Hey, molecular compounds. How are those different? First of all, molecular compounds are two or more nonmetals. So again, if you see a metal, you know it's ionic. If there's no metal present, that means it might be molecular. Now, there also cannot be any polyatomic ions present. So no metals and no polyatomic ions. So let me make an example. Let's say I have ammonium nitrate. Oh my gosh, Hubert. All right, and I'm going to pretend you guys can actually read that. So ammonium, NH4 plus, nitrate, NO3 minus. Those are both ions, right? That plus tells you that's an ion. That minus tells you that's an ion. The other thing to notice, though, is nitrogen is not a metal, hydrogen is not a metal, nitrogen is not a metal, oxygen is not a metal. So we have two or more nonmetals. That is a true statement about ammonium nitrate, which is formula, by the way, would be NH4NO3. That is a true statement about ammonium nitrate, but ammonium nitrate is not a molecular compound. Why is it not a molecular compound? Because it has polyatomic ions. Did you guys notice that? All right. So ammonium and nitrate are both polyatomic ions. They have those associated charges. Therefore, it is not molecular. It is ionic. So you just gotta be careful. So first of all, look for the metal first. If there's a metal, you know it's ionic. If there's not a metal, that means it might not be ionic. Doesn't necessarily mean it's not. So that's an important exception. And again, sometimes hydrogen makes molecular compounds, sometimes it doesn't. It just depends, but we're not going to worry about that right now. So why does it matter? So what's the point of making this distinction between the two? It's because we have different naming rules and different rules for writing the formulas. Yes, more rules, more things to remember. So the important difference for now is, one of the important differences is that molecular compounds are not always written in the lowest whole number ratio. So thinking back, let's say I have something like manganese 4 sulfide. All right, so this is ionic, and we know it's ionic automatically because we see that manganese with an associated charge. So Mn4 plus is that particular ion. Sulfide is going to be S2 minus. The crisscross method I taught you would give us the formula Mn2S4. Now, if you also applied the logic of the lowest whole number ratio, you would then go one more step and reduce that to MnS2. Right? So we would not write our formula for manganese 4 sulfide like Mn2S4. We'd write it as MnS2 because ionic compounds always go to that lowest whole number ratio, and 2 to 4 can be reduced to 1 to 2. With molecular compounds, we do not add that step. We write the molecular compound in the way it's written. So molecular compounds actually have prefixes that tells us what the formula is. And the reason we need those prefixes, which you will learn with the Chem question that helps you to give you, is that molecular compounds have many ways that the two different nonmetals can combine. So one of those most commonly referred to, just because it's a great example, is nitrogen and oxygen. Nitrogen and oxygen could be nitrogen monoxide, in which case there's one of each. It could be nitrogen dioxide, with one nitrogen, two oxygens. It could be dinitrogen tetroxide or dinitrogen pentoxide. There's lots of different ways we can combine nitrogen and oxygen covalently so that we end up with a molecule that works. So ionic compounds, there's one way to write them correctly. Molecular compounds, there's many different ways. And the case of transition metals, right, are kind of similar to that, because transition metals can have different charges, so we have to include that Roman numeral to tell you what type of ion are we talking about. Molecular compounds are similar in that they can combine in lots of different ways. And it's important to know which combination of nitrogen or oxygen we're dealing with, for example. So we write it using prefixes to indicate it, right? So I would say this is dinitrogen tetroxide. The di meaning 2, the tetra meaning 4. You guys will learn those prefixes on the Chem Quest and with the associated help sheet, but I just want you to understand why we're making this distinction. We have different rules that we have to apply. And of course, molecular compounds don't have associated charges to balance, right? So you would notice that nitrogen and oxygen, if they were ions, they would both be negative, right? And we wouldn't end up with a neutral molecule if those were ions of nitrogen and oxygen. So we don't have these associated charges. These are not nitrogen ions and oxygen ions combining. They are atoms combining in a different way to help them become more like a noble gas. And that's a whole different unit of study in the actual bonding for molecular compounds. All right, so I don't want you to worry about that right now. We still need to make this distinction because for the rest of the year, we're going to have to understand names and formulas to be able to move forward. So first question to ask yourself from now on, right, the rest of your chemistry career, when you see a name or a formula, is this ionic or is it molecular? make that differentiation based on the rules I just showed you, and then apply molecular naming rules to molecular compounds, ionic compound naming rules to ionic compounds. And you're off to the races. All right? So you guys need to follow this lecture up, of course, by answering the Google form questions on time, because I will get a timestamp of when you watched and took the Google form to make sure you get the full points for your homework this time. Peace.